Hello and good morning, everyone. Thank you very much for joining us this morning for this webinar. We're slowly getting started as people are joining in this virtual room today. Thank you very much for joining the IMPETUS Climate Solutions Forum, hosted by the UN Sustainable Development Solutions Network and the Climate Impetus Project of Horizon Europe. My name is Andrea Eratz. I'm the head of the networks team at the SDSN. And together with my colleague Sofia Kunic, I'll be your moderator for today's session. So as you might have seen when registering for this session, the Sustainable Development Solutions Network is a network of knowledge institutions that mobilizes universities, think tanks, research institutes around the world. And we do so to try and promote science-based solutions for sustainable development. Since 2012, we support the implementation of the SDGs, the Agenda 2030, and the Paris Climate Agreement. And we do so through education, through research, policy analysis, and above all, collaboration across sectors. And much of this is the case today with our speakers, with the different solutions that we're going to be discussing, and that we hope you can engage actively. So before we get started, just a very few housekeeping notes. We are recording this webinar so that it can be available also for your use right after. We will try to make the presentations and the recording available so that we can really promote some of the unique solutions that we're seeing in the Impetus project and across different European regions and demonstration sites. Throughout this webinar, if you have any questions, please don't hesitate to use the Q&A feature at the bottom of your screen. We will try to take one or two questions after each presentation and also keep some for the very end. You can also use the chat option to engage, let us know where you're connecting from, what field you're working on currently, and how you think you can contribute to some of these solutions, their replication or otherwise. So we are very excited to have here with us an excellent lineup of speakers, all dedicated researchers and specialists in sustainable development in different areas of climate change adaptation from the Impetus project. They will present to us some innovative tools, strategies that you will see range from various sectors and areas, speaking about behavioral change in tourism, about wetland innovations, about reforestation, about digital twins. So it's going to be quite fun and informative for all of us. So without further ado, we'll get started. I'll pass the floor now to my colleague Sofia Kunic, project manager at the SDSN, working on Impetus, who will give us an overview of the project and get us kick started. Thank you so much, Sofia.
Thank you, Andrea, and welcome everyone. So just a few words about the Impetus project. It was launched in 2021, and it's an EU-funded project funded through the Horizon 2020 program, focusing on transforming climate commitments into tangible actions that enhance resilience against climate change. It's a consortium of 32 partner organizations from 9 countries, and the project tests solutions in real-world locations, working with local communities, businesses, and policymakers to create strategies that enhance climate change decision-making. So we're working in 7 demonstration sites in Europe, in Berlin-Brandenburg region in Germany, in Catalonia, Spain, in the region of Attica in Greece, in Zealand and Vinmont, Netherlands, in Troms and Finnmark in Norway, and in Zemgali region, Latvia, and finally in Valle dei Laghi in Italy. So we have several representatives from these regions here today. And the central component of the IMPETUS project is establishment of so-called resilience knowledge boosters, RKBs, at each demonstration site. And these are hubs that facilitate collaboration amongst different stakeholders to co-design, assess, and implement climate change strategies. So they empower communities by providing data, tools, and best practices, and foster participatory approaches. So now that IMPETUS is in its final stages and final months, we would like to take a look at some of the solutions developed over the past couple of years, and to discuss their purpose and potential for replicability. So I think with that, we can give the floor to our first speaker, who is Fabio Pilotti, technical hydrologist at WaterJade. And the solution that he'll present is correlation analysis between meteorological and insurance data to support innovative insurance project for agriculture. So Fabio, the floor is yours.
Thank you, Sofia. I will share my screen. You can see it, I think. Okay, so hello everyone. Thank you for the opportunity to share the work we have done in this task in IMPETUS. I am Fabio Pilotti and I work as an hydrologist in WaterJade, which is a company that is focused on the hydrology but also on the meteorological data. And in this task, we use the meteorological data in order to understand if we can find a correlation between the meteorological data and the insurance data. In particular, in the context of this task, we have performed an analysis based on the data that ITAS, an insurance company in Italy, provided us in terms of policies and claims of agricultural insurance product. In particular, these data sets are explored and analyzed by URAC Research, which is another partner of the IMPETUS project, and they have performed an exploratory data analysis in order to understand the characteristic of this insurance data. And then with this filtered and cleaned data set, we have analyzed the correlation between meteorological and insurance data. So starting from their work by URAC, the exploratory data analysis followed this workflow, which is a detailed workflow of which we will see only the 2 last steps in order to focus on the main findings that they had. So the temporal trend analysis for claims and the exceedance probability curves for the claims, in particular weather hazards. So starting from the temporal analysis, what they have done is an analysis of disaggregation of the claims dataset in order to understand which weather hazard are predominant in the dataset. For example, we can see the total loss per year for each weather hazard, which are the drought, hail, heat, icing, rain, and wind. And they have disaggregated this one for the single hazard for year and also for summer, for a season, so winter, spring, summer, and autumn, in order to understand where we have to focus in order to capture the real problem in the main periods of the year, basically. So we can see that spring and summer are the critical periods for the agricultural crops because of the weather events that occur in these particular months. Another type of analysis is the disaggregation by year that they have performed, and we can see that the dataset is quite heterogeneous in the disaggregation between months, and is influenced, like in this case, for outlier, basically. So we have a big event in November 2019, which influences the whole dataset. So the starting point was to recognize this heterogeneity. Another type of analysis is the exceedance probability curves, which are the curves that states for each value of economic loss the the probability of occurrence for that particular economic loss or greater loss. And here we can see some of the major events in terms of economic loss. Here for the rain hazard, and also for hail, which is a quite different curve because of the fact that hail events are characterized by very high economic losses in a particular specific event localized either in time and space. So this is the starting point that URAC set it up, and we as WaterJade have conducted the correlation analysis based on this data set between meteorological and insurance data. In particular, this is the workflow that we have followed. So starting from vulnerability data and weather data, we have computed maps of vulnerability and hazard index in order to multiply it and try to map the risk in a study area and correlate this risk map with the claims data. So starting from the vulnerability data, we have tried to ask ITAS if they have an idea of which is the vulnerability of each crops, of each product basically, to the specific hazard, which is the rain excess. And they have provided this qualitative index, which ranges from 0 to 2, in order to understand for which periods is the specific crop, more vulnerable to the rain excess hazard. And from this data set, we have tried to map in a special way the index in order to link the policies that are present on the territory with the data of the crops. And we found that we calculated the vulnerability index map for the whole Italy in order to try to specialize also this information. And the weather data for this analysis is like the same, because we started from points on the territory, in particular ground weather station, and with a spatial interpolation we reached the municipality level, which is also the same level of spatial information of the vulnerability data and the claims data. And so we obtain, for example, rainfall data for this analysis of hazard, which is basically the rain excess. So we extrapolated from weather station only the rainfall data. So the vulnerability index, as said before, is a quantification of the vulnerability of the crops inside each municipality. And so we have a classification of this index for each of the periods during the year. In particular, here in this presentation, we will focus on April, June, and July, September, as we have seen before, the main periods for these weather events. And here we can see the map for April and June of the northern Italy, and also for July, September. And we can see that July, September represents the main periods for the for the main damages of this particular weather hazard. Going to the hazard index, we have tried to construct a weather index that can represent at the best this particular weather hazard, and we have accumulated the rainfall on 48 hours before the date of the event in order to catch the accumulated rainfall of that particular weather phenomena. And so starting from the hourly accumulated rainfall, we have interpolated and aggregated in order to get to the level of the 48 hours resolution in time. And then we have selected the maximum accumulated rainfall that occurred in the data set in each municipality in order to try to get the extreme precipitation map in this particular duration. And so we have a map of this hazard index also for the period April-June and for July-September. These indexes, I didn't mention it, but also the vulnerability and the hazard index are normalized between the minimum and the maximum value in order to get a normalization and compute the product in order to get the risk map. So going to the risk index map, here we can see an example. So multiplying the vulnerability index and the hazard index, we obtain this so-called risk index for each of the period, in this case April, June, on which we overlaid the claim dataset of ITAS in order to try to match the spatial correlation of the loss, the economic loss for this specific rain excess hazard on the Trentino South Tyrol region, which is the identified study area. And here we can see that in April, June, there is no particular match. In particular, we see that the higher risk municipalities are not corresponding to the higher average losses. In July, September, the situation is kind of the same, but a little bit homogeneous, because the risk enhances in all the study area, and so we can see that there is a little bit of a match between the average losses and the risk index in the maps. We have also performed the comparison between the relative loss, which is the percentage of the insured value of the crops that is subject to a damage, basically. And so here we can see also a quantification relative to the magnitude of the insured value, and we can see the overlay of the relative loss with the risk index. And also in July, September, the situation is kind of the same, but we wanted to take into account also this type of quantification of the loss. And here we can see some numbers, which are the correlation indexes in terms of Pearson indexes. And mainly focusing on April and June, we can see that the correlation confirm that the spatial distribution is not the same. And this was a main finding for ITAS, because they understood that the main risk in the territory was not corresponding to their main focus in ensuring the crops, and this will help them to focus on other type of municipalities in order to try to get a higher correlation value in this sense, and try to insure the crops that are more subject to this particular risk index. And this was one of the findings. Here I have reported some conclusion that we have done with EURAC and also with ITAS, such as the fact that the exploratory data analysis is something that they haven't performed yet, so they have basically understood something that they hadn't before. So highlighting different characteristics of their dataset they didn't know, and highlighting also possible factors and details that can be developed and analyzed in depth. Also, the correlation analysis highlighted useful insights, such as the fact that hazard and vulnerability, as well as the risk, has a quite correlation with claims dataset, but it can also be enhanced. And a further analysis can also be performed to acquire more knowledge. For example, here we have seen only the risk index for the hazard, but as you have seen in the beginning, there are other type of hazard, and they are also combined between them. So there are events that are complex in the sense that more hazard occurred in the same event, and so a detailed analysis on these particular events can be performed. So I have finished my contribution. Thank you. And if you have a question, I'm here.
Thank you so much, Fabio. This is very interesting, and congratulations on this amazing work. Maybe a couple of quick questions that come to mind. Given that you assess different crops, were you also doing some form of correlation when we see some of these maps that show vulnerability of a certain region regarding the precipitations? I imagine not all regions are concerned by same crops and same cultures, so hazelnuts are maybe grown only in some of those. Is there a way in this kind of tool to filter kind of what is the risk, what is the vulnerability for one particular crop?
Yeah, one example that I can tell you, but I didn't report it in the presentation, is that we have focused on apples and grapes, which are the main cultures, main crops in this particular region, the Trentino, South Tyrol, that I've shown in the presentation. And the match, the correlation between the claims and the risk was higher. Given that the specification of the crops enhances the capability of this tool to identify correlation. So, yeah.
Okay, fantastic, excellent. Thank you so much for that. The other thing that comes to mind, as you were doing this research, who were your kind of main interlocutors, kind of outside of your own institute?
As Waterjade, we basically collaborated with EURAC Research in the person of Massimiliano Pittore and Liz Calderon, because they were the point of contact between us and ITAS, the insurance company. And so basically the technical work was done by EURAC and Waterjade, but we had also several meetings with ITAS because they were interested to see and to help the analysis ongoing in order to try to understand also how they can help with their feedbacks and so on.
Excellent. And we got a question that just came in. Who was your main target audience to exploit this type of result of your research? I guess in part we can assume that it is the concerned municipalities and regions, but perhaps there is more to it, and as this solution also gets replicated elsewhere, no?
Yeah, it could be an example to be replicated. Mainly our they exploited by ITAS because of the fact that the data are protected right now on NDA, but is an example of how they can approach or other companies that can approach the problem, basically.
Excellent. Thank you. Thank you so much, Fabio, for joining us here today and sharing your great work. We hope to see more of it in the coming months.
Thank you for the opportunity.
No, thank you. It's a pleasure. If ever there are other questions, please don't hesitate to drop them in the Q&A. We'll make sure to get them to Fabio either today or later via email, and publish an answer alongside with this recording. With that, I would like us to turn to our next speaker, Anna Bocchesi-Urana, who is a postdoctoral researcher at the Institute for Research on Sustainability, Climate Change, and Energy Transition of the Rovira I Virgili University. The solution from the IMPETUS project that's here we're seeking to present is the one of pursuing behavioral change for climate resilient tourism on the Catalan coast. So we're changing the region, we're changing the solution, we're changing the approach. Anna, the floor is yours. Do we have Anna with us?
I think she left the webinar by mistake, so she should be coming back in a minute.
Okay, no worries. Let's see if she comes right back. Otherwise, we can move to the next speaker and come back to her in a moment. Do we see Anna? No. Okay. Well, we try to reach Anna. Jasper, if you're here with
Andrea,
us.
she's there. She's there. She was just in the waiting room. She's there.
Okay. Excellent.
She's joining.
Excellent. Anna, I hope you can hear us. We just got to your turn to present the Impetus solution on behavioral change for climate resilient tourism, and tell us a bit about your work with the Catalan coast. Please let us know if it is a good time to start your presentation.
Andrea, I see her joining, but it's like waiting. So just please go ahead with the next speaker.
Okay. Jasper, if this is fine with you, let's move on and pass you the floor. Again, we're working on a series of different solutions. So now we're going to be speaking about the heat awareness system, as Jasper is a flood risk management consultant at Nielen and Schurmans. Jasper, if you're ready to share your presentation, please go ahead.
Perfect, thank you. I will share my presentation. Let's see. And I hope all is clear now. Thank you for the introduction. My name is Jasper van Lieshout. I'm indeed a consultant at Nielen & Schurmans, which is an IT company. Glad to see so many of you joining us today. In my work, I focus a lot on developing technology such as systems, decision support system for climate risk management, normally about floodings, but we also do it for other climate risks such as heat, which I will talk to you about today. We already had a brief introduction about the Impetus project itself. As you remember, we are split into several demonstration sites. In our case, it's the Atlantic demo site, which is in the Netherlands. It's more specifically the province of Zeeland and Rijnmond. This is a very low elevated coastal region in the western part of the Netherlands. Traditionally, it has a lot of high flood risks, but it's also a major historical region of the Netherlands. It has a lot of socio-economic activity. The port of Rotterdam is located in this region, which is the biggest port in Europe. So it's quite an important region. However, heat stress is a relatively new topic in this region. I know most of you don't think of the Netherlands when talking about heat, but increasingly it's a growing issue with more and more hot tropical days. And currently not much is known about it. Also, our cities are not built for it. We also have older monumental cities which cannot be changed with not much greenery. So we have a lot of challenges in identifying what are these hotspots in the Netherlands, which are the hot areas, and what are effective adaptation measures. So we don't know really what the most effective are. So therefore, there's a clear need for actionable climate information, and that's where our part in the projects comes in. So our objective was to develop a heat awareness system to support decision making, and we're trying to do this by turning climate information into practical, easy to understand information. Sorry. We aim to bridge this gap by quantifying heat stress. But first we have to define heat stress, because what is heat stress is clearly different than, for example, droughts or just extreme temperatures. And to do this, we have developed or used a heat indicator. And this heat indicator, which is the physiological equivalent temperature, is developed by the University of Wageningen. And it's basically means how hot does it feel, the experienced temperature. And this empirical indicator has been tested a lot in the Netherlands, but are often require a lot of climate data to make it very specific. And in the Impetus project, we have further worked on this indicator to see how hot does it feel in different areas. And for example, displayed on the figure in the left, it is in Dutch, but I'll talk you through it. What the indicator does is looking at how hot does it feel, and this means this can vary, of course, on very much location based, but also what are you doing, the radiance. For example, if you're sporting in the sunlight in a big square in a city with a lot of reflectance, radiance, it might feel a lot of warmer than, for example, if you're in the shades with winds blowing with not much activity going on. But to compute this, it does require a lot of information on all these different factors: climate data, local data, environmental data. personal data. And for the Impetus project, we have gathered all this to compute this index. But then we have only the index. We didn't have the tool at the start, so we involved the stakeholders from the beginning. We did various iterations of stakeholder engagements. So if we're going to develop a tool, we want to focus our tool on the end users. End users in our case are municipalities mostly, but also construction companies. And we want them to have a tool that they can use in their goals and ambitions. So we have various involvement of the stakeholders. Just to summarize, at the start, we did an inventorization of requirements. What do you need from the tool in terms of applicability, resolution? How can it support your goals and ambitions? We also had 2 student researchers for the university on this topic on how to match stakeholder needs to practical tools. In later stages in the project, we also did some co-design workshops where we took their initial requirements, constructed them, and presented it back to them to see, is it good like this, or do we need refinement, or are some things not as we planned? And now currently we are in the stage of early adopters, pilot case studies, which I will talk about in a second as well. So what did we develop? Is a system you can see here. It's been fully operational for quite some time now. It's a decision support system that functions on a very high resolution. It's up to 1 meter by 1 meter spatially. It's a cloud-based system, so it can be run and accessed through your standard web browsers. And what it does is it quantifies the local heat stress in the demo site by using this heat indicator, the physiological equivalent temperature, and shows it in a 2-day map. And with this tool, municipality stakeholders can now easily identify where local hotspots in their city are and evaluate different climate scenarios, but also adaptation scenarios. In the example you can see right here, it's 2 scenarios. On the left one, you have a scenario in 2024. In this period, trees have grown significantly at the location more in the left of your image. And on the right side, you have a scenario of 4 years or 5 years back, where you can see the trees were not developed yet. And in the vertical part, they have cut some trees actually in the recent years. So you can clearly see the effect it has on the heat stress on a very local level over the years in this case. The tool is fully interactive, means the users can pen, zoom, interact with it in real time and get rapid information on it. But they also can apply their own adaptation measures to this tool, and that's what's present on the left side. It's again in Dutch, but I will talk you through this as well. From the top to bottom, users can, for example, change the vegetation in the area by adding trees, other types of vegetation in different sizes. It's an important factor in the heat stress as it can provide shades, but also absorb some reflectance from the sun. They also can change the land cover, for example, to grassland, water features, urban areas, bushland, all sorts of adaptation measures municipalities would like to take against heat stress. Thirdly, they can also choose to completely redesign their urban space. So they can remove buildings, they can add buildings, and they can also upload complete urban development plans in this tool based on typical design formats by architectural companies, and test then directly the effects on the heat stress. And with the technology we develop, we can do this recomputation in only seconds. So you can very rapidly see the results of your actions. And a combination of what I showed you and a successful early adapter is shown in this case. The tool is named used by the municipality of Leiden in the Netherlands, which is quite a large city, I think 150,000 inhabitants. And the municipality of Leiden actually uses our tool already to test and evaluate all their new urban development plans in their city on heat stress. And they're working also to implement this into their policies. So as you can see in the video you see here, they have created their own urban development plans, maybe by an architectural company, and they have uploaded it in our tool. And in our tool, they can see what the effect on heat stress is. And this can include parks, buildings, water features. But it can be completely free up to them what they design in this. And if they don't like it, they will just do it again, a new design, and they can test again what the effects are. So they have a nice way to make the city more climate adaptive. Another use case of our work, not specifically on our tool, but mainly on the foundation and the results within impetus of it, is that we as Nederlands Grumman's are now the official national provider of the static heat stress maps. So the base heat indicator, we have made these available freely, open source, and these maps are now available for the complete Netherlands on a 1 by 1 meter resolution. And they also now are the foundation of the national current and new policy on climate adaptation on heat stress, which makes me a little proud to say that we are the official providers, and is a nice showing that the work within impetus can grow quite large. As I mentioned, this data is also fully open source available, so you can look this up if you want and see how it is in your location. So in the end, just to summarize a little bit, I think the positive impacts of our tool can be best summarized by translating technical data, or heat data in our case, into realistic but easy to understand information for both experts and non-experts. It can help, for example, citizen engagement. It can show heat stress in an easy to understand manner, making citizen engagement easier. They can talk with citizens, they can talk with experts, and they can talk about the same topic without this knowledge barrier. It can also, as I showed you already, help spatial planning. They can make better or climate adaptive cities with it. They can test their plans and see how it will make the most adaptive city. And in the end, we support data-driven decision making and better choices in terms of spatial planning, but also in policy in many different aspects. So thereby, I want to conclude my presentation on our developed heat tool. If you think our work is interesting, have any questions, or want some more information, feel free to contact me. You can also send a QR code just to go to our website. You will find me there. And with that, I think I want to thank you all for your attention and already enjoy the other presentations after me.
Thank you so much, Jasper. It was incredibly interesting to see even the demo in action. I think it really visualized well for us. And congrats on being the official provider of the solution. I think it's really amazing. Maybe just one immediate question. You talked about all the different stakeholders that you involved with, municipalities, governments. Maybe you could tell us a little bit more about how this worked. Did you have any particular challenges or lessons learned, something you could share with our audience, either before or now in the piloting phase?
Yeah, true. We did have a lot of conversations with different stakeholders. So we had different stakeholders. We had mostly municipalities, but we found that the municipalities are not really experts on what to quantify. So they were mostly practical focused, which is logical. But in the end, we also had to include experts from universities. We had to include citizens. We had to have this whole range of people invested in the system and giving their feedback to provide the result everybody would be happy with. And we found in the beginning we didn't have that, so we had to change that a little bit. But in the end, it worked out nicely.
Great, thank you so much. Now in the Q&A box, I see someone asks if you could provide a link. I guess we can provide a link to the IMPETUS website, but if you have anything also from your side.
I'll look what I can share in the chat. Yeah, that
would be great. And then I see we have one more question about tree plantation. Someone asked about the impact of that on the global warming. I don't know if you would like to.
It's a little bit out of the scale of our study. I do think it has a positive impact, in this case, reducing, of course, the effects. It's a little bit out of the scale for study for this now. But interesting question, yeah.
Exactly. I think something to think about for all of us. Great. Then thank you so much, Jasper, and thank you for providing the contact information. So we'll share that, and people will reach out to you for any needs or further questions. Now let me see if we have Anna back with us.
I'm here. I don't know if it's gonna work now, but
we hear you well. So
I was listening to the first, and then when you present me, it was out the presentation. So I try now.
No worries. So maybe then we can move to you. I will just say again that Anna, you will present the solution pursuing behavioral change for climate resilient tourism on the Catalan coast. So yes, we can see your presentation. Please go ahead. Thank you.
Okay, well, good morning, everyone. I'm Ana Buque. I come from the Center for Climate Change in Universitat Rovira i Virgili. This is in Spain, southern Catalonia. So I'm going to present the work that we have been done in the IMPETUS project that is focuses on how tourism can be more climate resilient. So, and we did this study in 2 different areas in southern Catalonia. The main concepts that we put together to do the research are the idea that climate is a potential that is it makes a region or a tourist destination able to host different tourist activities, but this also can be a constraint depending if this climatic potential that the region has, it can harm also the destination if we have these changes in different meteorological parameters. So we have to consider that tourism is also a sector that has is experimenting the impacts of climate change. And also we include the topic of the dune ecosystems, that if in the Catalan coast we have a lot of sand and beach tourism, and this is done in the shore, we have beaches. So if we don't have the dune ecosystems, we don't have the space to do this kind of tourism. And in particularly in Catalonia, we have like a loss of the 90% of these spaces have suffered serious deterioration. So in our project, we join these concepts, the climatology and also the erosion on beaches and the ecosystems loss. So the objective of our task is to understand the perception of territorial agents about, from one side, how the influence of weather and climatic conditions are in the tourist activity, and also we explore how the stakeholders perceive the importance of the beach dam systems in the shore. And for do that, we use historical photographs. So our case study is also in the IMPETUS project, but we focus on the Catalan coast, and we do this in 2 specific tourist destinations that are Costa Daurada and Terres de l'Ebre, that these are the ones that are more in the south of where they are on southern Catalonia. So what we did is a methodology that is based on 3 steps. First, we focus on the stakeholder engagement. We try to include different stakeholders regarding the tourism sectors. That means all the business that offer tourist activities, hotels, municipalities, tourist offices, and so on. Then we did 2 co-creation workshops, one of each in the different destinations, tourist destinations. We tried to with this work to give some more insights in the Catalan strategy for adaptation to climate change. And in the co-creation workshops, what we did, it was to give some knowledge builds first, and then we asked the stakeholders different things that now I will explain. So we did different round tables with the stakeholders focusing on different topics. Here I will present the results of the round tables regarding weather, climate, and climate change, and the other round table focused on beach dam systems. We also worked with the water and energy topics, but they are not included in this presentation. So what we did is to use a methodology that we already had from previous projects. That is a methodology, a co-creation methodology to develop climate services. So we have a structure methodology where we put different heterogeneous stakeholders in the same round table, and we ask how they feel that meteoclimatic conditions impact to their activity. And from this, we we have for different destinations and for different sorts of tourism, how the different meteoclimatic conditions impact to the activity, from the best conditions to the harmful conditions, and we have also all the range with the perception of how these conditions impact to the tourist activities. Here is an example of sand and beach tourism. This is not my beliefs. This is the consensus between the different stakeholders that they were in the round tables. Also, we have the same perceptions, but for different activities. This is for indoor gastronomy and outdoor gastronomy. And then also for the other tourist destination, that is Terres de l'Ebre, we have different specific tourist activities, like guided visits in the delta, or more in the mountain area, called sports. And for each different activity, we see how these conditions are beneficial or constrain the activity. Also, what we gather from these workshops is knowing the good or bad conditions for the activity, but also we gather adaptation measures regarding different time scales, considering what meteoclimatic conditions are good or bad for the activity. So this is to highlight the value of different time of having the weather or climate projection in different time scales for each destination. This is for Costa Daurada destination. And also we have here the measures, adaptation measures identified for Terres de l'Ebre destination, according if they will have best conditions or worse conditions for their activities, and which adaptation measures they will do in different time scales. Also, it was the results regarding the climatological side, but also we have the results of the big stand system, which is focused on asking questions, on showing photographs to the stakeholders, and see like real photos from the moment and photos from the past, and see the differences on answering the questions. And we found that the points of view of the actors, once we show different photos from previous years, the perception it changes a lot. And then also we want to highlight that all this work, it's important to be shared with the community that we develop the workshops. So we appear a lot in the media, and also this was more for the perception side, but also we transform all this perception information to data that helps decision making to adapt the tourist activity. So what we did with all of the meteoclimatic parameters that we identified in the perception workshop, what we did is to develop co-created indices that assess the climate potential for tourism. And we got the climatological data, the historical data from oceanographic observations, and also from the atmosphere. And from that, we compute the indicators, new indicators, tailored from the perceptions of the stakeholders. So for each point in the map, you can see that we have different points that are the different locations in these two different tourist destinations. And for each one, we have the different sorts of tourism activities that the stakeholders have identified. And we got the climate potential for the whole period. And also we have like a summary of during a calendar plot showing for each sort of activity and for each location, tourist location, which sort of activity has more average of daily optimal days per activity. So this work is helps to put like more tools or ideas or ways to be more tangible the Catalan strategy for adaptation to climate change, because the Catalan strategy for adaptation to climate change says that there is a need to diversify the offer, but there is no clue on how to diversify. So if we know the climate potential of the different tourist activities, tourist destinations managers are more able to say, okay, in this area I can focus more in this sort of tourism and in this specific period of the year, and so on. Also, as we consider climate, but also we consider the beach dam system, this approach is an integral view of pursuing this behavioral change to the tourism sector. But of course that this tool that we have created, it needs more work, because it's a thing of behavioral change of all the stakeholders that are involved on this sector. So this is a tool that can help to make decisions and see where is best to invest and where not, and in which moment of the year. And then also regarding to the beach dam system, we see that if we integrate the geohistorical evidence into participatory processes, it's a good way to improve actors' awareness about the ecological changes. Well, and here you have my contact, and if you have any question, I'm just here to answer you.
Thank you very much, Anna, for sharing some of your work across the Catalan coast. I was just wondering, would you be able to give us any examples of actions or decisions that were taken locally with the following this methodology? Any modifications in the offer?
Well, for the moment, we are not yet in the moment that we share the tool with the stakeholders. But I think that it's going to be very useful, because we don't include tourist-specific activities like general. They are so specific from, for example, for Delta, it has specific guides, tours, so it's so local. So I guess and wish that this tool is going to help more focus it on and feel like more that it's there in like for property of them, because it's so tailored. So I guess that it will, once we share with them, it will be useful, because we are starting to have more, because here the summer is specifically July and August is where we have more tourism, but now we are starting to have more like a sport tourism and I see some municipalities that they now start to offer more in the other months. So having this information, it could help them more to know which sports or other activities they can offer without the summer season.
Okay, so if they're smart enough, they would read some of your methodology, get some of the, as you say, tailored solutions, and try to also create some economic activity beyond the peak season. Bring in some tourists and make tourism a little bit more sustainable. Great. Okay, so since you also speak about how tailored all of these approaches need to be to each coast area and so on, how would you say this type of solution could then be replicable elsewhere? Is
Yes.
it something that needs to be taken from scratch each time that I don't know, that you would like to apply it to, let's say, the northern coast of Spain or a beach in France?
Yeah, it's not a problem to replicate it because because we have done this in different tourist destinations. For this project, it's just in the Catalan coast, but we already did from Italy, Mallorca, well, in different areas for tourism, and also we did for other sectors, for agriculture, for infrastructure. So we have the experience enough to have like the same, because it's a 3-step methodology, the co-creation. And once we gather that information, what we create after is in the same methodology, and it will compute local local specific indicators. So it's not a problem to reply it. It's more a thing of thinking of the right topic or sector and engaging the real stakeholders that then they can use that.
Understood. Excellent. Well, thank you so much for joining us here today and sharing your work again. It's really amazing, the variety of solutions that were brought together under one single impetus project from the Arctic to the Mediterranean, and so on. Let us move on now to our next speaker, Christopher. I hope you're ready to join us and tell us a bit about the early warning system for geological and avalanche risks. So a little bit of a different climate, a little bit of a different solution. You are a postdoctoral researcher at the Arctic University of Norway. Thank you so much for making it today with us and to speak about your work within the Climate Impetus project. We're very eager to hear your presentation.
Yeah, thanks for having me. So to be a little bit more specific, I'll be talking about slush flows. It's a type of kind of snow avalanche. And this work I've done together with Louise Vick and Vilda Hansen. And we'll talk about kind of developing decision support tools for slush flows in northern Norway. Can you see my slides?
Yes.
Yes, okay. So first, I think I should get into what is a slush flow, because it's not so obvious to even a lot of people that live amongst them. So here's a picture of a slush flow that crossed a county road. This happened kind of in December, just before the holidays, and this shut down the road for 2 days. And this is a road that leads to several small communities. It's the only access road. So the people living there had to contact their local fishermen and take a boat around the fjord to get access to grocery stores in the town and hospitals and so on. So a slush flow is a rapid mass movement of soaked snow, so very wet snow. And they're becoming more common as we have warmer and wetter winter periods. It's kind of the little brother to snow avalanches. So in this talk, I'm going to kind of introduce the scope of this problem, and then I'm going to kind of poke into 3 different risk mitigation kind of works that I've been doing within the Impetus project to try to get slush flows kind of understanding under control a little bit more. So the extent of the problem is, you can see here on the left, there's a map of Norway, and all those red dots are data points of when slush flows occurred, or where slush flows occurred in Norway. And this record goes back to 1951, with most of the data being collected in the last kind of 10, 15 years. So what we can conclude from that is these slush flows are a problem kind of all over Norway, also a problem outside of Norway, but I just have data on Norway. This histogram here shows when slush flows occurred. We can see a dramatic spike in occurrence in 2020 and 2021. I think this isn't a real spike in activity, but rather a change in the reporting system. It was community-driven reporting of these events, and I think a lot of them were misclassified from wet snow avalanches, and it seems like that's been taken under control now. So we can say that there's about 5 to 20 slush flows that are being reported in Norway yearly. But we also know that these are drastically kind of underreported events and misclassified events. So often slush flows get reported as an avalanche or a debris flow. And so the data we have on this is quite poor. And that results in quite poor decision support tools and risk mitigation measures for this type of hazard. So just to draw a parallel, I want to introduce kind of the risk mitigation strategies we have for snow avalanches up here, which is quite robust. We have good data sets and kind of well established. So we break this down into kind of short-term and long-term kind of mitigation strategies with both direct and indirect. And so we can kind of go through some of these, and the indirect short term is like developing policies and procedures for how to behave when kind of forecasts of avalanche danger is high. Indirect long term is spatial planning and hazard mapping and hazard zoning, and creating laws saying you can build certain infrastructure here, like schools and hospitals can't be located here, but maybe you can locate a garage in this hazard zone. You have direct short term, which is RACs, that's remote avalanche control. So that's when you have these towers that bomb an avalanche down, kind of controlling the exposure. So if an avalanche is coming down, you can have a gate that comes and stops a road, stops traffic on a road, evacuations of buildings and communities. And then direct long-term would be kind of construction measures, building a tunnel to protect a road, or a deflection dam, also protection forest, which isn't super relevant for where I'm sitting up in the Arctic. The forest is quite weak, but every year we see the tree line creep up the slopes. So now if we look at what's been developed for slush flows, it's a completely different story. We have kind of what I've highlighted in yellow is we have a regional forecast, but we're missing a lot of the pieces there just because we don't have a great process understanding. We don't have great data on this. There's a few construction measures that have been built on very active slush flow paths. I know of 3 of them in Norway. But this kind of mitigation strategy is missing quite a bit. So within the work of the IMPETUS project, I've been trying to kind of fill in this mitigation strategy with 3 small kind of sub-projects. So I've kind of developed some guidelines for a site-specific avalanche forecast. I did some kind of initial steps for hazard mapping, which is the basis of your zoning and kind of spatial planning. And I've did some data collection and process understanding stuff that helps the overall regional forecast. And so we can get into those now. So the first one I'll talk about is this site-specific forecast for slush flows. So this is aimed at people and infrastructure that are exposed, that have a high exposure time to slush flows. You can see at the kind of photos at the bottom right, there's a digger that's buried in the snow and a car that's flipped over and half buried in the snow. And kind of all these pictures are from the same event. In the middle picture, if you look close, you can see that also. So it was a road construction crew working this one day, and they got hit by a slush flow, and even a small one had quite a bit of power to completely destroy a car and a digger. And so what I've done is I've created kind of a few guidelines. When we see that the kind of regional slush flow forecast is elevated, then you can go into the field and look for danger signs in the terrain, in the snowpack, in the weather. And then kind of these guidelines point you to areas in the terrain where maybe you can spend some time, and then areas in the terrain where you should definitely avoid when we see those danger signs. So that's a site-specific avalanche forecast. And that's being developed, distributed to municipalities, road construction crews, and people who are kind of spending extended periods of time in the exposed areas. The next small project is a slush flow hazard mapping. So this would be the basis of any zoning laws. So here we took some avalanche runout models and adapted them and developed new parameterization for them to try to work on slush flows. So the problem we have with this is, I mean, the models look good. You can see in the map on the right, it's maybe a little bit clearer. You have some red and blue colors, and these are simulated slush flows where we think that they would run out and where we think they would start. And then this is a model that can run regionally, or I mean, in all intents and purposes, it could run for all of Norway, and it would take just a day or two to calculate. But more data is needed for validation. So this model, we've kind of come up with the methodology and come up with a parameter set, but we need a bit more data for kind of validation and making that parameter set a little bit more robust. But the methodology is there, and it's easier to kind of make something better than start from scratch. So we have version 1. And then kind of the last little project that I've been working on in this is a slush flow classification system. So this is a kind of system where we make a standard for data collection. So we get the high quality data when an event occurs. And this is kind of basic research that will push forward the process understanding of slush flows. And with the greater process understanding, we'll be able to make better decision support tools and risk reduction measures. And this is some of the process understanding that came from this is currently being kind of used in the regional forecast. So the regional forecast is being updated with some of the process understanding we gained in this process. And so the key takeaways for this is that slush flow mitigation and strategies are very far behind avalanche mitigation and other types of natural hazards. And with warmer, wetter winters that we're experiencing up in the Arctic, we're going to see more of this type of hazard. But steps are being made with the IMPETUS project and other projects to kind of get better data for slush flows and push the process understanding of these greater. So thank you.
Thank you so much, Christopher. I think it was really, really interesting, and this kind of underrated topic. To be honest, we haven't heard about it much, even within like well-being and impetus. I think it's really interesting to know more. Just maybe an immediate reaction. You said that you're working obviously on Norway, the slush flows in Norway, but you said that there are also others in Europe. Have you been in touch with other areas, or are you planning to kind of explore that through other projects?
Well, currently it's mostly a Norway problem, but as kind of everywhere winters get wetter and kind of more erratic winter storms come in, where you get snow and then rain on snow, these are going to be a problem popping up around the world where you have seasonal snow cover. So they've had slush flows even come down Mount Fuji in Japan. So I have been in touch with several other kind of researchers, but it's not at the top of the radar yet because these are really uncommon in the Alps, for instance, a bit more common in Sweden and Finland.
Okay, great. Thank you so much. I was curious about the Alps too. And maybe just another question. Now that the project is kind of coming to an end in a few months, are you kind of thinking of the next steps? Like how will you be further trying to sustain the solution or work on it further? You mentioned a lot of data that's missing. Do you have any Any plans?
Yeah, we have some kind of steps in place. When there's slash flows that happen around here, we put a priority to go out and document them, and whether that's flying a drone and getting pictures or just reaching out to contacts who are working in the area on the roads or something. So we're collecting more data, and there's kind of a few more interesting experiments we have going on. One lab experiment that I'll have a master's student working on, where we'll be trying to develop a better parameterization for some of those run-out models, looking at kind of a process-based method.
Okay, great. Thank you so much. That's really good to know. So thank you, Christopher. I think we'll then move to our next speaker. It will be Konrad Landis, who is the postdoctoral researcher at the Athens University of Economics and Business. Konrad, I think you're with us, and the topic is the risk factor calculator and SCBA tools. So please tell us more about that.
Thank you so much, Sophia. And first of all, I want to thank SDSN for organizing this very interesting event. And hi everyone, I'm Konrad Landis. I'm senior researcher at the Athens University of Economics and Business and adjunct professor at the Athens University of Economics and Business, and a senior researcher at the I4IA network, the Alliance of Excellence for Research and Innovation in I4IA. So today I will speak about two of the tools. I will present two of the tools among those we developed during the IMPETUS project, and this is the social cost benefit analysis and the risk factor calculator tool. And actually these are part of a collection of tools built in the project to help regions in developing their adaptation pathways. That is the optimal portfolio of interventions in different time periods towards reaching the resilience. And so these two tools actually can be used as criteria throughout this process. And mainly the social cost benefit analysis tool referred to help users calculate the net present value of expected cost and benefits from different interventions and types of interventions, integrating mostly the economic externalities. And the risk factor calculation tools helps shortlist different interventions based on their hidden risks and cascading effects in relation to their implementation and long-term feasibility and sustainability. So some words about its tool. So the social cost benefit analysis tool, as I said, it works in calculating the net present value for expected cost and benefits for 50 different types of interventions against 10 climatic hazards: sea level rise, flooding risk, water scarcity, marine storms, fires, biodiversity loss, health diseases, temperature increase, avalanche increase, and extreme storms. So now, as from the underlying framework, as I said, the model quantifies tangible but both intangible in relation to externalities, benefits related to externalities. So it includes both the market aspect, that is capital expenditure, operating expenditure for the implementation of the interventions, but also it quantifies in economic terms the externalities, the benefits in relation to ecosystem services or other social factors. Now, the underlying economic models, these mainly uses meta regression models such as benefit function, value transfer function, econometric methods. It uses an underlying database, vast database of more than 5,000 primary evaluation studies, mainly through the two most known databases in environmental economics, EVRI and SDV. And also it handles different discount factors in the calculations of net present values between market and non-market benefits. So it does calculates the decline social discount rates to discount the non-market values for the non-market values in the valuations. Okay, now the framework we follow, it follows the common methodologies as they have been the most common methodologies following the Millennium Ecosystem Assessment of 2005. And as far as the classification of the ecosystem services and the different categories, the different environmental assets under provisioning, regulating, supporting, and cultural ecosystem services. And also all models use a very extended set of factors to account for different sources of heterogeneity, with an emphasis also on the European biogeographical regions. So now these are actually easy to use tools built both in Excel and Python. So Excel to be easily used by users, and Python to be easily integratable with rest of the tools built in IMPETUS. Actually, the tools are very easy to use. The user needs to select the NUTS2 level region for the implementation of the intervention type, the hazard type, needs, of course, to define the capital expenditures, the operating expenditures of the intervention, and also the implementation years. And mainly the tool calculates the net present value of each one of the interventions, together with the ranking between the available intervention and also their cost effectiveness. Okay, so it is a tool that helps users shortlist between different types of interventions applied in different horizons, but also it calculates an aggregate for the entire portfolio of solutions, and aggregate benefits to cost ratio, which this can be used. It's useful when user wants to compare different portfolios of interventions to be included in the pathways. So the underlying models assumptions, as we said here, it's the estimated econometric model, benefit transfer function values. These, of course, in the Excel version of the tool, these models are periodically updated by the Athens University of Economics and Business. And the, as I said, it supports the EU27 and Norway regions, and it uses NUTS2 level socioeconomic data. Also, on the background, there is also a machine learning algorithm that is based on an extent literature review, and which actually maps the different types and the different interventions to the different types of ecosystem services impacted by the intervention. Now, as far as its impact and replicability, this tool, as we said, it intends to support decision making, as it provides with, it enables a comparative evaluation between different types of interventions or different portfolios of interventions. It prioritizes, so to prioritize on high impact and cost effective adaptation options. Also, it's scalable and replicable, as it can be used outside of the context of the project and IMPETUS. It can be applied actually to EU regions, and with it's in our intentions to modify this tool moving forward to also account for, to also be able to be used in continents outside Europe. Now, as I said, it's fully integrated with the other IMPETUS tools and the tools that have been built by the National Technical University of Athens and the MAIH, the Mediterranean Agriculture Institute of Chania, into the Dynamic Contingency and Response tool. This is another tool offered by IMPETUS. So in short, this tool can be used as a criteria that can be used together with other criteria in shortlisting between interventions. So economic criteria, it's not the sole criteria that we do care about when shortlisting on different interventions. And we think it has its potential, it's open access, and it promotes the uptake from public authorities, NGOs, or the private sector when during the design of the action plans, shortlisting interventions when we design action plans. Now, the second tool, which is works closely with the social cost benefit analysis, is the risk factor registry calculator, where it identifies and shortlists actually interventions based on their hidden risk and cascading effects in the effective implementation of these interventions. So 10 risk factors are included, spanning political, economic, social, environmental, and technical dimensions. So now, for these 10 factors, the tool internally includes 53 key performance indicators that measure adequately the level of implementation of each one of these 10 factors. Again, data at the models work at both national and NUTS2 regional level to ensure multi-scale applicability. Now, as for the background models here, we do calculate different risk scores for the different interventions, intervention types. And this is actually an econometric scoring model that uses historical data for all of these 53 KPIs and for the 10 risk factors from 2010 to 2022 from various publicly available sources such as Eurostat, World Bank, etc. So now also the KPIs are normalized across countries, regions, and also a composite risk score is calculated at intervention level as a weighted sum of all the different risks to the different factors. Okay, so now as I already mentioned, these scores actually varies by different NUTS2 level region, by different countries, by intervention type. But in order to be able to account for the heterogeneity in context-specific vulnerabilities and implementation barriers. So the model also accounts for interdependencies and compounding risks between the different risk factors. Again, 2 words for some very specific details for the tools. Again, this is an easy-to-use Excel-based tool where a user needs to define the NUTS2 level region, the hazard, the intervention type, and the outputs are 10 risk score for each one of the risk factors, as well as an aggregate score for all factors and for the portfolio of solutions. Okay, so it's everything in relation to the taxonomy, the different types of interventions, fully aligned with the social cost benefit analysis tools, and it covers, as I said, 279 NUTS2 level regions and the EU-27 and Norway. So now, in relation to the impacts, this tool again helps users in identify high-risk interventions before their implementation. So, which are the different factors: social acceptance, stakeholder engagement, financial conditions. Okay, all of these factors, and be able to prioritize the different interventions based on their high or low probability of successful implementation. And of course, it supports cross-sectoral governance and promotes transparent and evidence-based policy making. Again, it integrates perfectly with the other criteria and the other tools built for the design of adaptation pathways in the project. And of course, though, it can be used outside of the impetus context in any of the EU regions, and it's easily adaptable for including more risk factors or more KPIs for more localized data for the specific KPIs. And it's really useful for national, regional, local authorities across different sectors and globally while they are developing again their action plans, their adaptation plans. So thank you. Here's my contact also details, and you can send me any questions. I think our tools have not yet uploaded to the SharePoint, but they will be shortly.
Thank you so much, Conrad. It's amazing to see you, to see and listen to you so passionately speaking about all these tools. It is a very complex set of tools, I would say, that you have come up with, and probably we could dedicate it in an entire webinar just to that one. But you've kind of already answered some of the questions that I had lined up for you with regard to the replicability, the who are the end users of these. So thank you so much for joining us here today and sharing your work. It is very, very precious. I wouldn't add any other questions, and I don't think that would help us stick within the time limits for today. So without further ado, I would pass the floor to our next speakers, to two colleagues, Neil Alvarez and Faye-Emily Weaver, Head of Climate Solutions and Ecosystem Services Unit at EURECAT Technology Center of Catalonia, and Biodiversity Standards and Indicators Assistant at the Center of Mediterranean Cooperation for the International Union for Conservation of Nature. We're about to hear about the below sea level multifunctional wetlands that would help us adapt to sea level rise. So again, a very unique and diverse solution, all developed within the IMPETUS project. Neil and Faye, thank you so much. The floor is yours.
Hi, thank you, Andrija. I think I just shared the presentation. Is it on full screen? Because I have two screens. Yeah, okay. Thanks for the introduction and for having us here today. As you say, we are going to present this work together with my colleague Faye, because that was done along with a collaboration between EURECAT and the IUCN. I will start explaining you the pilot itself, how it was designed, and the conceptualization of this pilot, and then Faye will show you how this was evaluated as a nature-inspired solution, also to decide if that was a good solution to be implemented in a larger scale. So a little bit of background. This is our pilot location on the study site. We are again in Catalonia coast in the Ebro Delta, which is in the northeast of Spain, and as many other deltas in the Mediterranean Sea and in the world. Here we are facing pressures from climate change, such as sea level rise, lack of sediment flow, increase of habitat loss, and also it's vastly occupied by rice farming. That's the similar setup for many other deltas in the world. So our idea here was to test a novel and a innovative wetland that could tackle pollutant removals from this rice system to the ecosystems. Because as you can see in the first image, a very big area of the delta is occupied by rice fields. This agricultural activity contributes to flow pollutant loads during the rice system. Here you can see also how the current system of naturalized constructed wetlands centralized is working. And I wanted to show you this graph, which is the background of our work here that we have studied earlier in 2018. And we could see that this is the amount of concentration of pollutants of emerging concern that is entering the natural habitats. So this is the outlet of the rice system. That's during the rice growing period. And in here you see how this centralized unit that you can see here a little bit better is performing. So this is the current situation now in the Ebro Delta. We have two big centralized wetland systems that filter water before it's discharged to the natural habitats. They work nicely, but they filter only a little bit amount of the total runout water of the Ebro Delta. And here is where our idea started to test another system, a complementary system that will be a decentralized and technified constructed wetland. We needed it to be technified because as the size will be way smaller than the constructed natural filter, some active materials need to be added there so the pollutants are removed in a similar efficiency. Those systems are designed to be implemented at the end of every rice field. So in this way, a lot more of this runout water will be filtered rather than if we have only these two systems that you see here in red. We have one in the south, one in the north. So with this idea, we started tested materials. So we did the pilot design in a laboratory. We tested different materials, as you can see here, and we used water from the Ebro Delta River, spiked with some of these pollutants to see how these active materials will react and how they will reduce and eliminate these pollutants. The first batch experiment showed us that the biochar and the whole pellets were the more efficient, and then we followed a methodology by Lee to decide not only based on efficiency removals, but also on particular size, how environmentally friendly was this, cost analysis, and many others. We decided which of them were worth to be tested in a more scaled pilot. Then we conducted these experiments in the lab still with column, where we tested both sand plus biochar in a 10%, biochar at 30%, and shredded pellets. So those were the materials pre-selected and tested in a filter. In here, we simulated the flow that we will expect in the real environment. So after that, based on the results and the cost analysis, we decided to construct our pilot with this mix of biochar at 10% combined with sand. Then we went to the field. We designed a pilot that was a multifunctional system because we wanted to test not only our guess, which was the sand and biochar as the most effective filter for removing pollutants. We also wanted to test how natural water flow will react, and also if we could work with only sand, because that would be way cheaper and maybe more scalable in the next step. So that was our design. We had 9 cells. We pumped water from the discharge system during the whole growing season, which ran from May to September 2023. We simulated a natural drainage flow of a rice unit, and we conducted analysis every week during the farming system to see how this was performing. So basically, the water was pumped, entering the filter. It was a subsuperficial filter. So the water will flow through this cell, which was not very big. It's only 5 meters per 1 meter as a test cell. And then we will be collecting water both from the inlet and every outlet to test the efficiency of these filters during the whole season. Here you have an image of how we were building this and how it looked at the very beginning of the experiment. Then the vegetation took over, and we did not clip that because we wanted to see also how this biomass will work as a phytoremediation system as well. Here are some results very briefly, because I think I'm running out of time. We've seen that during the growing season, as we expected, our filter filled with sand and biochar was constantly achieving highest removal efficiencies, but we've seen also that the other 2 filters had the ability also to remove and to degrade some of these pollutants. So this confirmed our conclusions from our lab experiments. And after that, we also, or simultaneously to that, we also performed, as I said, together with the UCN, an evaluation of this solution as a nature-inspired solution, and that is going to be explained by my colleague Faye.
Thank you, Neil, and good morning, everyone. I'm going to give a brief overview of how we evaluated the multifunctional wetlands solution using the IUCN Global Standard for Nature-Based Solutions. There's various definitions of nature-based solutions. Here you can see the IUCN and European Commission definitions. And despite some minor differences, they're based on sustainably managing and restoring ecosystems and natural processes in order to address societal challenges. The IUCN has published a global standard for nature-based solutions, which consists of 8 criteria, which you can see here, which each have several indicators. If you could go to the next slide, please, Neil. So in addition to the growing recognition of the importance of nature-based solutions, the IUCN standard also acknowledges that a wide range of different solutions are needed in order to address and adapt to large-scale environmental challenges like climate change and water pollution. And these include nature-derived solutions such as wind and solar energy, and nature-inspired solutions as well, which imitate processes found in nature but are not directly based on functioning ecosystems themselves. So this multifunctional wetland solution uses natural materials and is inspired by the natural filtering qualities of wetlands, but since it does not directly rely on a natural functioning ecosystem, it's considered nature-inspired rather than a nature-based solution. However, we still decided to evaluate it using the standard for nature-based solutions, which is not just a tool to assess whether a project is a nature-based solution or not, but can be used to evaluate a solution's sustainability and its environmental, social, and economic dimensions, as well as helping to guide its potential for upscaling. So here you can see the graph that was generated when we evaluated this solution using the IUCN online self-assessment tool for nature-based solutions. And you can see that overall the solution achieved a positive degree of alignment with many of the indicators of the standard. For example, for criterion 1, which is about the societal challenges, the wetlands are directly designed to address the issue of water security, and also have the potential to indirectly address other challenges such as human health and environmental degradation. And under the 3rd criterion on biodiversity, the solution has the potential to produce ecological benefits if it were to be implemented on a wider scale. However, since it is currently a pilot experiment restricted to a single field, several indicators were not applicable, and this also contributed to lower scores for some of the indicators. So to achieve greater impact through the implementation of this solution across other rice fields throughout the Delta, it would be important to take into account the nature-based solutions criteria, such as the habitats and species, the sustainable management of the filter materials, and the inclusion of relevant stakeholders in the governance of the project. Next slide, please, Neil. And so to conclude, evaluating this nature-inspired solution using the standard helped us to identify aspects which would need to be addressed in order to upscale it. While the pilot constructed wetland has shown positive results and demonstrated its potential as an effective tool for reducing agricultural runoff pollution, a holistic approach is necessary. So if the solution were to be integrated within part of a wider network, combining different types of wetland solutions and infrastructures, as well as addressing the biodiversity considerations, it could shift from being a nature-inspired technology towards becoming part of an effective and sustainable nature-based solution or a network of solutions. And this would require significant coordination and planning, but has the potential to enhance ecosystem resilience and address complex societal and environmental challenges on a wider scale. Neil, I don't know if you wanted to add anything else.
Yeah.
sentence to conclude. Thanks, Faye. As we said, we've seen that this has the potential to really contribute to pollutant removal and further contribute to conservation, biodiversity gains, and so on. But we have seen also, and we have faced some concerns. We did have a workshop with farmers, so we discussed the scalability of this solution, and further research needs to be done in efficiency of this, long-term efficiency of these filters. Also, more research is needed to understand the duration and the effectiveness of this filter, as well as also the who will pay for the cost of the implementation of this system if it has to be scaled in a larger area, and that's something to be done in the future for scaling up this. So that was our presentation. Here you have our contacts. We'll be happy to give you more details if needed.
Thank you so much, Neil and Faye. That was really, really comprehensive and interesting. Actually, you just answered my question, because I saw the picture with the farmers, and I wanted to ask how the stakeholder engagement went, and if you have any insights from that. But I think we kind of understood that there are still some challenges, right, that you need to solve, and kind of how to replicate it. I don't know if you want
Yeah.
Yeah.
Indeed.
Yeah. Okay. Well, thank you so much. I think we don't have more questions, and we're running a bit short on time, so maybe let's move on to the next, the final speaker for today, which is Stelianos Manudakis, a research associate at the Mediterranean Agronomic Institute of Hania. And Stelios, you will tell us about reforestation and biodiversity monitoring tool. So please.
Thank you, Sophia. Thank you for the presentation. Thank you for hosting and inviting us as well here to present our solution. So as you can see here, it's a solution that was developed around the Attica region under the IMPETUS project, which tries to aid into the reforestation and biodiversity monitor efforts that are being right now assessed in the Attica region. As Sophia said, I'm part of the Indigo research team and affiliated with the Mediterranean Agronomic Institute of Hania. And it seems that I cannot change the slides. Now I can. So if I can say, forest degradation is a well-known issue, especially when climate change is coming into the play. But specifically for the Attica region, just for the Attica region in Greece, the last 7 years, from let's say 2017 to 2024, Attica region lost 37% of forests, its land cover, which was characterized as land cover, which corresponds to 45,000 hectares. And then that's just from wildfires, not accounting all other issues that's coming into the play. So Attica faces many environmental challenges, from the frequent wildfires, the hot, dry climate, and the forests that are fire prone. And this is also causing significant biodiversity loss. When we're trying to tackle this, meaning for restoration and ecosystem protection efforts, urban growth, soil degradation, climate change, of course, but also insufficient funding and the short-term thinking of the stakeholder and policymaker are greatly affecting those efforts. So what we're trying to do here is to create a service using modern tools, machine learning algorithms, and remote sensing data that enables stakeholders and users relevant to the restoration efforts to monitor forest loss, forest biodiversity, and how those effects are changing through time. All those analyses and the results that are coming, they're being used to generate restoration proposals in areas where forest degradation is detected. To make it more comprehensible, what's under this service, we can say that there are like 3 tools that are being developed. The first, the monitoring forest degradation, where trying to detect for the Atco region where forest as a land cover is being lost. Secondly, how biodiversity is being changed and where. And ultimately using this information, along others, of course, to propose some reforestation strategies to add to the decision-making approach. So, and I've seen this question popping up a lot, but I was going to cover it. We're trying to produce a solution that's going to be scalable and replicable, meaning that right now it's being developed for the region of Africa, but as it is, with very small adjustments, can be also be demonstrated in other region of the Mediterranean, and with further adjustment to other regions of Europe as well. So to achieve that, open access datasets that are available throughout Europe. So I'll guide you through a bit from where we started and how we achieved the result. And in the end, I'll make a short demonstration about the tool itself, which is an online service. So in order to monitor the forest degradation, the first thing we did, and it's rather simple, is that we're having two different satellite pictures, and we're feeding a model multiple data to help it understand where the change is happening. So as you can see here, the results from some classification models. We tested a lot of different classification algorithms, and the ones with the best results I'll also presented and demonstrated in the service. Have produced really nice results, and we can actually monitor where the forest is being lost, not only to wildfire. As you can see, the image on the right is an image from the National Observatory of Forest Fire in Greece, but also forest degradation happening due to other reasons as well. So this concludes the first tools where we're able to detect where the forest degradation is happening. Moving on, the second tools that I described, and I'm going to describe further, is the forest biodiversity recognition tool, where we're trying to identify forest species and their change through time, which is rather, I can say, not a simple task actually in terms of using remote sensing data. It's very difficult, and it's very difficult to correlate satellite data and of spatial resolution of 10 meters with ground truth. But what we had in our hands is the Lucas Land Usage and Land Cover Area Statistical Survey, where it enabled us and gave us access to point data where we knew what type of forest goes in each region. And you can see here the samples and the points corresponding to the Attica of region. So our species recognition is being based to the classification of the Lucas sampling dataset. And we built a lot of, again, classification models, and you can see here some of them that are being worked, that those images are from a conference that they were presented right now. And those two tools, as I mentioned earlier, are feeding the third, which is the forest restoration. The title third is wrong, where we take the tweak to approach that first we need to learn how the stakeholders are doing the assessments right now. And mean by stakeholders, the people that are into the decision making and having the trigger to assess, but also implement those restoration efforts. So thankfully, we have with us the environmental ministry here in Greece as a partner, and especially our partners from the reforestation service, the administration of it. And we had access again to multiple restoration studies implemented, not successful or not as well. So we learned from those, and we learned that what is the information that they are using right now, and what's the mindset and what's the final outcome. So based on that, they're doing an ecological evaluation. It's a data-driven approach. And what they're trying to do for each area that's deemed to be restored, they determine the restoration strategy, specific to the area, of course, and a list of species that need to be planted. With that in mind, what we did, we used a model, a machine learning model, with data coming from the restoration strategies, and those are studies that are actually documents. And what we did, we extracted from those documents, as you can see here in a small table, of the important information that could lead to a restoration practice on the right. And our goal is and was to create a spatial decision support model that is able to compute area-specific forest restoration proposals. And right now, I'll change to make a small demonstration of the tool itself. You can exit here through the link that I just presented. Can you see the screen? Thank you, great. So what is important to have in mind that this is a tool that is aimed and co-developed to the stakeholders and actors related to the restoration efforts. So at the back of our head when we were developing these tools is that we needed and we wanted to bring together different groups, communities, and stakeholders closer to the forest research community, so that we can actively support policy making and in the end well-informed decisions. So really fast, I know we're short in time, that you can see here that this is what is developed so far, and we're still developing this, but it's working this real time. Everything is on the cloud and it's real time calculating right now. So I picked a date range so we can identify what was the forest loss between those years. So it evaluates what's the biodiversity change here and in what's present in each species. Also, where the forest loss is being detected. Okay, and the biodiversity change in terms of species here. And let me close this. And of course, we are providing the restoration suggestions for the change that happens till present time. So you can see here that the stakeholders have access to information that's not loading correctly. So to where they should focus first, and also what type of solution they should provide as suggestions. Okay, so you can see here that two different restoration suggestions are being proposed here, but also to promote, let's say, the well-informed decision aspect. There are multiple data sets that we know that they are going to use, and they ask us also to include with information that will help them with the decision making. So that's all from me. Thank you. And if you have any questions, I'll be happy to reply.
Thank you so much, Stelios. This was really interesting and probably something that we should all test a bit and play a bit with the tool. I was wondering, what are some of the initial feedback that you're receiving, maybe from some of the target audience and decision makers? Do they see any potential in this, and kind of have they already tested it on some areas that we see in the red there?
So thank you for the question. So indeed, yes, and as I mentioned, the stakeholders were heavily involved in this process. Thanks to Impetus, we had multiple workshops and an opportunity to collaborate. So we actually listened to them and we tried to bring to the table what we asked for us to bring to them. So this this last iteration of the tool, let's say, was presented to the stakeholder like 2 weeks ago, and I think it was really interesting for them. I mean, they already know of the tool, and we know that they're going to adopt them at least at the scale of the administration of reforestation service in Athens, for example. And hopefully we will listen from more, let's say, other stakeholder and users that will actively be interested in that in our service.
Fantastic. Thank you very much for sharing that. And if you were to do it all over again, is there anything that you would have changed or done differently? Or if somebody asked you if they were to do it in a different country, in a different region, anything you would advise not to do or to do differently?
Yeah, many of suggestions, but I think in our cases and most of the cases when it's coming to decision making and modeling is give me the best that you have. The best resolution possible, and we'll provide the best results we can. I mean, yeah, that's a general rule.
Yeah, I imagine a good data, good resolution, so that we can zoom into as much as possible. Wonderful. Thank you so much, Stelios, for taking
Thank you
the
as well.
time, sharing your work. Thanks to you and to all the other speakers for all this great lineup of super insightful presentations. And to all of our audience for the time and engagement, and for all those who will be learning about these solutions when watching this recording. Thank you so much. It has been a true pleasure to work with all these researchers and putting some spotlight on their work. As we mentioned earlier, and as Marta is now putting in the chat, do feel free to reach out to the SDSN and the Impetus project on any of the initiatives that you have seen here. We will be sure to connect you with the right person. We'll be circulating the recording as well as the links to the presentations shortly after this webinar. It has been a true pleasure again. Thank you so much for all your contributions. Thanks so much to the SDSN team who made this possible. With that, let's bring this session to a close, and hope to see you again at a future event. Take care, everyone.
Thank you so much.
Thank you so much.
Bye. Thank you.
Bye.
Thank you.